Hello chemistry students, this is Mr. Nicholson and this is the second video in a series on separation techniques for the separation of mixtures. In this video what we're going to do is we are going to take a look at the separation of dissolved solids from liquids, and by dissolved solids we're actually going to often refer to those in chemistry as solutes. Alright. And likewise, we're also going to refer to the liquid that they're dissolved in often as the solvent. Okay, that's just some jargon for you to understand when it comes to actually talking about the mixtures when you have a solid dissolved in a liquid. Alright, let's look at our first technique, evaporation. Now this technique is pretty straightforward. The physical property that it actually relies on exploiting to separate our dissolved solid from our solvent is boiling point. Alright, most salts, when they're dissolved in water, for example, they actually, as the salt itself, have a really high boiling point. If not in the hundreds of degrees, in the up above 1,000 degrees. Alright, and so what we're able to do is we're able to heat the mixture and boil just the solvent. Alright, and so just using a very simple setup as shown just here, if we have a heat source and we heat our mixture in an evaporating basin, what we'll be able to do is we'll be able to actually evaporate just our solvent, leaving behind our salt crystals. And as the amount of liquid there in our mixture actually decreases, what will happen is the crystals will form. Salt crystals will form, and that will actually begin to come out of solution and crystallize. Now, one thing of note with this technique, and you have to be very careful with it, and it's a safety precaution, is that as you actually are evaporating your liquid component of the mixture, if you do that too quickly, if you boil it too quickly, or you boil it dry, which essentially is amounting to the same thing, it can often spit, and that'll mean you'll lose some of your mixture, which is something you certainly don't want to do. You want to get as much of your materials as possible in any chemistry you're doing, but you also will put yourself in danger and put other people around you in danger because it'll be spitting really hot salt. Okay, and that can, if it lands on your arm, burn you quite badly. It can easily get in an eye, which is why you should always be wearing safety goggles at all times in the lab. But you can avoid this by leaving about a 50-cent size piece of liquid in the bottom of the evaporating basin and turning off your heat source and just letting the residual heat in the evaporating basin evaporate away the last amount of that liquid. And that's all there really is to it. It's a fairly straightforward technique. Alright, let's take a look at our second technique. Now, crystallization is actually a pretty interesting technique. It relies on the physical property of solubility, specifically differences in solubility between salts. It's actually quite common to have a mixture of salts when you're actually performing chemistry, because not all chemical reactions are going to go to completion, and not all materials that you're going to be handling are necessarily going to be pure. And so what that means is that you can often be left with a mixture at the end of a chemical reaction. Now, that doesn't mean that you are stuck with a mixture. You can actually quite easily separate out a pure salt or pure compound really easily, quite simply by actually manipulating the solubility of the mixture. Now, if you heat up your mixture to the point where both salts are soluble and then carefully cool it down, what will often happen is that one salt will selectively come out of solution, and you can aid that by getting a glass rod and scraping it across the bottom of the beaker, and that'll make a couple of little chips in the glass, just little tiny ones, and that'll act as a little seed, a little nucleus for the salt crystals to form around. And you just need to seed your actual liqueur, which is what the actual solution is called in this case, and that'll cause the formation of crystals to form. Alright, And what will often happen is this will actually be used to purify mixtures of two or more different salts. Now, purify does not mean pure. It simply means that you're going to have more of one salt actually come out as a crystal. You still will have both salts come out as a crystal. So your salt B crystal, as labeled just here, it will still be a mixture of salt A and salt B, but it'll be mostly salt B. Likewise, your solution will contain mostly your salt A. So it is a little bit of a challenge at times to recrystallize solutions effectively, but it's a powerful technique that lets you clean up the product from a reaction by recrystallizing it and getting rid of other materials simply by taking advantage of differences in solubility. And so just remember, you do this by heating it up to when both are actually soluble in the solution, and then carefully cooling it down and letting one of the salts crash out of solution. Alrighty, that brings our second video to a close. Thank you for watching. And what we're going to do in our next video is we're going to take a look at the separation of two or more liquids. Okay, thank you. Bye.